Hello, everybody. Today we are doing a slightly different type of natural selection in Scratch. So, we've covered this before in a different video. If you don't know what natural selection is, you can go to natural selection explained in Scratch. But here we're gonna simulate natural selection with heat. As you can see, there's a little bit of different stuff here. Now you can see a blue gradient on the left and a red gradient on the right. And so the red is hot and the blue is cold because we're doing temperature. So as you can see, we're gonna start off. It's random, okay? So there's a lot of things going on over here. So first of all, we don't depend on food in this simulation. In fact, we depend on the temperature. As in real life, if we are in way hotter condition that we are supposed to, we will die or not reproduce. Also, if it's colder than how much we should be, we don't also reproduce. So here we're gonna simulate with those rules, creating this kind of grouping simulation. So I'm gonna start off with just no turbo mode because so we actually talk about what's going on, and then after a bit we're gonna turn on turbo mode so we can speed up the simulation and see what happens. So we start off with just 10 little cubes, okay? As you can see, they have different colors depending on their position. If they're hot in the hot region, they appear more pink. If they're in the cold region, they appear more blue, okay? So now if we click space, we can see what's like their temperature and their average temperature. So the left side of what they say is what their temperature is currently. And the right side of what they say is their average temperature, which is basically the temperature they was born in and they have to stay in so they reproduce. Here we have blue ones. These are like a group of cold ones that have been adapted to much colder regions. As you can see, some of them even are surviving in the most harsh regions, such as 0 Celsius. In the other side, we can see that there is very hot regions, such as 26 or 27 to even 30 Celsius, which is very hot. But these guys are adapted to different types. So if I just drag one to the other side, they won't be surviving at all. And we also have the Twilight Zone, other known as the Goldilocks zone, and it's like where we have a purple blue color for each square. So if I check here, the average of the Goldilocks zone is 15. Yeah. So the middle temperature is 15, which is for us it's not really if we lived in this simulation, it's not really good for us. It would be a little chilly. So we would survive in an area that's like 23 to 27. 30 gets a little bit too hot, so technically the side of where it's like a magenta instead of pink is actually where we would survive the most, okay? So as you can see, there's a lot of stuff going on. They are reproducing because they are inside the correct spot. And now if we speed up, you can see that they're moving much faster because of turbo mode. And as you can see, they tend to stick a little more to the right side instead of the left side. As you can see, there is a small group, but they're completely isolated from the right side group. As you can see, they start expanding and start sending little signals, but they eventually get wiped out because they aren't in the correct temperature. And still, small sparks of groups can still appear randomly, not so frequently, but if we restart the simulation, there is a high chance the sides would be changed. But for some reason, it seems that the cubes are most adapted to the right side, which is the hottest side. Like the hot pole, except it's like usually in reality the hot side would be reversed, and actually the equator, yani the middle, horizontal middle would be the hottest area and the rest would be blue. But for now, we're just using a more simple approach because I'm not in the mood to code a lot of stuff because this is just a simple example. But now that we know what's happening, I did one wrong. I seriously. It's an example, my man. It's not supposed to be so complex. I mean, I wanted to code, but it's not supposed to be complex. It's supposed to be simple. So, as you can see, the right side has shifted to the left side. This is also a very rare occurrence, but it's just by chance. So they have to stand by luck instead of actually moving or mm, migrating. But technically, this is harder to make migrations since we haven't do the realistic Earth pole like temperature. So technically, it's more or less likely for them to migrate from the top to bottom because that's where they are, you know, like in the good area. Okay. So now that we've covered this, we can go and check out the code. So as you can see here, there's an additional bar which is runtime options. This is because I'm using TurboWop instead of Scratch and I use extensions that are different from the extensions from normal Scratch. Yeah. But it's only one because I just needed to speed up a little bit more so turbo mode won't be really laggy because if there's a lot of clones, turbo mode is a piece of dingler. Anyway, so what we have is a bunch of variables. We have average temperature, radius of temperature, which is just
Radies? You have radies?
yeah, reproduction chance, which is basically the chance of them to reproduce. The reproduction twin group, which means if it can make more than one baby per reproduction like cycles. And the final is temperature, which measures the amount of temperature that the cube is in. So it does by a simple equation. It does round 24 plus x position divided by 15, so it makes a stable, like, and by adding 240, this makes it easier to like do stuff. So then the right side won't be not that hot and be like 15, and the other side would be negative 15. So tweaking it up by 240 makes it from 0 to 30 instead of negative 15 to 15. And here is just the loop of reproduction. As you can see, it's like duplicate, so if they don't manage they have a second chance, and if they don't manage they're just dummy. And this is the movement script, and not it's really unnecessary technically, but I don't mind because technically it would make no sense if the creatures wouldn't move around. So this is how natural selection with temperature works. It could be a little bit more advanced if we added food and predators, but for now we're not gonna do that because for simplicity and so the quality of life goes up, we're just gonna use one sprite instead of many so we don't increase the lag, and I'm not in the mood to add an equilibrium zone because that would also be a pain in the dingler. So yeah, I hope you enjoyed. Don't forget to subscribe and like my video and other videos. And if you enjoyed, yeah, thanks for subscribing and liking if you did. And bye bye! Don't forget to watch my other videos. So bye bye.